Hello. In the last two videos, you have seen how we can take an existing Docker image and deploy into OpenShift. We looked at an example of an application where you took a MySQL database Docker image and deployed it into OpenShift. And then we took um, a PHP application, which was also built as a Docker image and then deployed into OpenShift. Right? Now, in this video, what we'll be seeing what we call S2I process, which is S2I stands for source to image conversion. And this is a process where OpenShift will take your application source code and build a Docker image for it. You'll see how simple it is to do so. I'm going to do this using a web console. So let me log on to the web console first. This is an OpenShift Beta 4 installation. I'm logging onto the web console. Now, let me first create a project. A project is a placeholder that it's kind of a namespace which includes uh, all the application that you want to run. So I'm going to create a project. Now that the project is created, you can see that the project is empty. There is nothing inside it. So now let's add our first component to it. Just like before, we are going to create a MySQL database in this project. And this time, instead of doing it in the way in which we did before, where we were pulling an existing Docker image by using a command line, by deploying a pod that runs MySQL uh, database, this time what we are going to do is create it from what we call a template. A template, it describes a set of resources that are intended to be used together. So when we are trying to quickly spin up a new application, it's easier to use templates. So I'm going to select the MySQL template from here. This template provides some parameters that you can pass. So I'm going to edit these parameters. I'm going to give a password for my MySQL database, a database name, let's call it sample, and a username. I'll just call it Veer. You can also set up some labels, and I'm going to add some labels here. I'll say the name of this component is a database. Uh, so add the labels, and then I'll say create. Now this will be created as part of the my PHP application project. So what it will do is it will spin up a MySQL database that runs as part of this project. So as you can see on the console, it's actually spinning up a new MySQL database, spin up a pod that runs a MySQL database, and it front ends that pod with a service, a database service, and this database service is routing traffic on this IP address and on port 5434. By default, MySQL uses 3306, and the port 5434 is forwarding from 3306. So as you can see, the database is now running, and it is front-ended by this service. Now let's explore this web console a little bit. If you click on this browse button, you'll see different kinds of things that you can look at. Let's look at what pods are running. It's running a database pod with this name, database1 XNS8X. I can also view this from my command line. If I say OSC get pods like before, it'll show all the pods that are running. So the same database pod is running here. You could also see the service and the IP address of the service here and the ports exposed by the service. Now I'm going to get inside this pod and add some data to this database like before. This time I'm going to use OSC exec command. Uh, this will allow me to enter inside the pod. I'll supply the pod ID, and I want to enter the bash prompt. So now from my local machine, I am entering inside the pod, and I have the bash prompt displayed here. Now let's access the MySQL database to the IP address of the service. The port number exposed by the service is 5434. Now I'm logged to the MySQL database. If I say show databases here, it should show the sample database that we wanted it to create. And then I'll use the sample database. Let's add a table and insert some data. Exit this pod. This is just to show you an example of how you can enter into a pod from your desktop. Now that we added the database, I'll now add a front end to a front end application to access this database. I have my source code in a Git repository. As you can see, the source code is in the form of a PHP file. I have a simple PHP. This is the same as what we have used in the previous example. It will connect to the database and it'll display the list of users from the users table. As simple as that. So what we are going to do is supply this source code to OpenShift and let it build the image from this source code. That's the reason why it's called source to image conversion. Select the GitHub's URL and I'll go back to console, and this time I'll create by using this GitHub URL. I am selecting a builder image, and since this is a PHP application, I'm going to select the PHP builder image, and I have to name this application. I'm good with db test as a name, and there are a few other parameters that you can set, and this is still evolving. As of now, you can create a route for this application, but you can't edit it from the console yet. So we are going to add that route manually outside. You can provide some deployment configurations. We are saying that it's going to auto deploy when the new image is available. The build information, it has configured that the source code is the GitHub repository URL that we provided, and it'll automatically build a new image when the code changes. It's yes, and it's going to automatically build a new image when the builder image changes as well. So whether the source code changes or the PHP itself changes, it'll trigger a new build. And let's add a label here. We'll call it PHP front end. And then I'm going to say create. Now what this does is it'll spin up this DB test. Now if you look at the builds here, you have a new build called DB test created, and it is pointing to the source repository which is on GitHub, and I can start a new build now. This process has started a new build with the name dbtest1, and the build is running here. From the command line, if I say osc get builds, I should see the same build again here. And if I want to see what is going on, I can say osc build logs to look at the build logs. It has actually pulled the source code. It has converted the source code and took the builder image, and it built an image for my application. Now it is trying to push this Docker image for this application into a local registry that is running in my OpenShift environment. This is the local Docker registry that's in my environment. This is going to take a minute. You can see this has successfully pushed the image, and once this image has been pushed, the application image has been deployed into a pod with this ID that you're seeing here, and this application is now running in a pod on node 2 right now. So this is the process of source to image, where you give a source code, and that source code has been converted into a Docker image. It has been registered inside the Docker registry that is running on my OpenShift environment, and it has automatically taken that image and deployed it into a separate pod. Now this pod should now talk to the database pod, but before we check that, we'll have to add a route to this application. Let's look at the services here. You can see that the database service from before is still there, and there is a service for the data DB test, which is the front end that we created. But it by default it adds a route here, but this is not useful at this point. So what we'll do is add an additional route for this application that is externally accessible. I'm going to add this route manually for now, and this application will be accessible using this URL. By issuing this command, I have created a route for this application now. Now you can see that the route is now added. Now let's access this application using this route. And here are the two records from the database. What this means is the front end code that we just added, the dbtest.php, is connecting to the database and it has accessed the two records that we added before. So to summarize what we have learned in this video today, we have created a project on using OpenShift's web console, and we have added a database in that project by using templates. Then we have created an application front end that talks to this database by using the source code, and we OpenShift, by using the source to image conversion process, OpenShift has converted that source code into a Docker image. It pushed it into a Docker registry running on OpenShift, and then it deployed that Docker image as an application on running as a single pod in OpenShift. Thanks for watching.